welcome back to the education track. So next up we have Renee, and this is, guess what? Renee. Renee is one of those doer people, and what exactly does she do? Kind of everything. So she is a cloud developer advocate on the Python advocacy at Microsoft. She is CEO and co-founder of Tech Inclusion, best known for the Girls Programming Network, which runs workshops for girls all around Australia. On top of this, Renee started her own business, Connected Code, bringing tech education opportunities to school. And recently, Renee was awarded Champion of Change 2025 by the Women Leading Tech. And fun fact, she also has 2 cats, Artemis and BB. So let's welcome Renee.
It's not all work, there's cats in there as well. Thank you, Ali. Hello everybody, super excited to be here today to present my talk, whodoneit.xlsx, how we can teach Python through data investigation. As we just heard, I do a lot of things. Basically, they all come down to tech, education, community, squished into some form together, and I really love context-driven learning experiences, which we've already heard a lot about today, so hopefully this is a nice extension of that in a slightly new landscape. Today I'm going to talk about the world of Python, data, and AI in 2025 in the education landscape. What is Python in Excel? Framing your own crime for educational purposes only. Then we're going to solve the crime, and then I'm going to tell you how you can apply this to your own curriculum, hopefully. Okay, so here we are in 2025. What are we doing in the technology landscape? We have a couple of questions, really, when we're kind of trying to teach kids technology, whether they're new, whether they're super engaged, wherever they are on the spectrum of knowing stuff and liking stuff. How can we teach Python in a fun and an engaging way? Is there a way to make it feel more comfortable, familiar, a place that we could do that? And is there an alternate approach that means that maybe they can't just go to ChatGPT and get it to solve the problems for them? Because we do want them to learn a thing. Why do we want them to learn a thing when AI can do it all for them, theoretically? Well, from my own experience, AI can be a really useful tool. I know, as a person who works at Microsoft, I'm using Copilot a lot, and it is a really helpful tool. But that is because I actually have been working as a developer for 10+ years, and I do know what I want it to ultimately do. So it works best when I can give it specifications about the stack that I want it to use, the requirements that I need to have, and the context that I know that I also know that it doesn't yet know. So that's really useful. I also know the limitations and the options of things that are available. So I know not to ask for things that aren't realistic or, are going to go a little bit awry. And I also know that sometimes, especially when the context is large and I've asked it a lot of questions, it kind of can get a little bit off track because it doesn't really know how all these pieces of context actually fit together necessarily. So when that goes wrong, either I can work out what's gone wrong and can prompt it in a specific way, or I can prompt it, or I can just go around the AI and do it myself and fix out the problems that maybe are too complex for it to actually deal with within the scope of my project. So to be able to do that, I did need that 10 years of experience as a developer, so we do need kids to actually keep learning to code. Even as the AI tools get better and better, we need them to have that understanding, and you get that understanding by doing. So I have been working with a lot of data recently, and I've experienced some of these problems firsthand. I've got to say the AI was great when I was like, yes, I need this simple calculation done really fast, but the more data I added in, and the more complicated and the more connections the data had, the more it kind of got a little bit iffy in terms of like, how is it all going to fit together, and the code kind of didn't work anymore. Like, if I had a better mental model of all this that I created, that would be great because I'd be able to quickly fix it, but right now, I have a lot of AI-generated code, and it doesn't have the full picture of things that it needs to have. Thank you to my lovely husband, Jack, who is getting me out of this meeting that I'm not going to on my phone. Okay, so that thing is that AI isn't great when there's a humongous picture, which happens when you have a lot of data that you want to work with. So how can we get kids to work with a lot of data so they too can experience the joy of working with their own data and finding out the hidden details in it? So this is where Python and Excel comes in. But first, I'm going to tell you a little bit about Python and Excel before I tell you about this mystery that I have framed for us. Okay, so what is Python Excel? Well, you already know how you can write formulas in Excel. Now you can write Python in Excel in cells. So you can just do equals pi and hit tab, and now you have these fun little green pie boxes, and you can write Python in there. And you don't just have to write a single line of Python. You can actually write many lines of Python, which is really cool. The cells actually work together as well, so we can see a equals 5. I can now use a in the next cell down, and you can see that a plus 2 is 7. So you can do this for many cells, which is very exciting. If you're like, oh, but I want to write a lot of code, and it's going to be hard to see it in those tiny cells, don't worry, there's this Python editor where you can see all of the code, which is really handy. And you can also see the stuff that you want to print out, because as you can see here, you might go print hello, and the thing is, print hello prints the thing, but it doesn't return anything. It returns none. So you're going to have that printed out, which is not what you want to see. But what you do want to see is the thing that you printed out here in your interpreter here. So that's really helpful. Other things you might want to know about Python Excel is you can insert it with this, once you go to the data ribbon, you can insert a Python cell. If you don't want to write the 3 characters of equals pi, you can click a button instead, don't worry. If your interpreter ever gets stuck, you can reset your environment and it will just run all your code again and connect up properly again. You've got the editor to pop that out, and you've got this initialization button, which will show you all of the stuff it imports before you actually start coding. So these are all the things that you don't need the children to see, but will already be built in when you load Python in Excel. Most importantly for this demonstration is pandas, or pandas as PD, as it will be shortened to in the examples. So, how do I get some data into my Python in Excel? It's super easy. I've made a little pi cell. I just go and highlight some data somewhere, really easy, and then it does all of this information here for me, which is great. I didn't have to type any of that. It figures that out. It figures out the headings, hooray. And now I'm going to assign it to a variable, student attendance, which is handy. And now I have this data frame. Once again, it doesn't print out the whole data frame, but you can see it if you need to here by doing show data type card, and you can see all of the wonderful data that you've loaded in, which might be handy to be like, what was that data again? Oh, there it is. So we have some data. We can also print out all of that data in the interpreter as well. Okay, so why would I want to use Python in Excel? Well, it's a familiar place. Lots of people have used spreadsheets before. And if someone's new to coding, oh, I don't know how to do coding at all, potentially other teachers who are like, oh, no, I couldn't do coding. I'm not a techie like that. I was like, well, do you know how to use a spreadsheet? And they're like, yeah, of course. Do you write the functions in that? Oh, yeah, I've done a function from time to time. It's a friendly landscape. Who wouldn't want to do something in Excel? It's a wonderful tool. What I also think might be useful is it has a clear link to variables. Variables are a topic that is commonly hard for students to grasp at first. But if you've been using spreadsheets for a while, even if you've only done some basic formulas like cell A1 plus cell B2 equals something in another cell, you've used variables. They don't have very fun names. They're called cell A1. That's a variable name. And people know that if I put different data into that cell, the formula answer is going to change. So I'm hoping that this will be a way for students to more easily grasp some of those concepts. Finally, Python Excel means, you saw how easy it was to grab that data. I highlighted a thing. It worked all the stuff out for me. It means I get to skip the stuff like reading a CSV and doing with open, blah, 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 looping through a thing, filtering that data out. It's actually super fast and easy. And so you can skip that part and get to the fun part of solving a mystery. So, the interesting thing is, though, when I first came to Python in Excel, I'm like, cool, I've done a lot of spreadsheeting. That's really cool. I've also written a lot of Python code. Bringing these two together is going to be super fun, and I'm going to definitely intuitively understand how I can use this new tool in this new landscape to do something fun. But at first, I was just like, okay, I'm going to do this. I'm like, no, I can just do that in normal Excel. And then I started doing another thing. It's like, well, I could do this with Python, but doesn't really need Excel. It doesn't really make any sense. So it was this new kind of paradigm that I had to kind of get my mind around of how to join these up and use the skills that I have in both in a different way to solve different kinds of problems. So I found the kind of two things that I end up doing most in Python Excel isn't your normal Python, I wrote a script, has a lot of loops and if statements and things in it, and it isn't your kind of normal there's like filtering, and you've got sorting and things that you can already do in in Excel, and you're like, well, why would I need to do something else? So I found that firstly, being able to index a whole series of data is super useful, and indexing it by name. And then secondly, being able to map a function or some sort of process to that data, like a column or whatnot of your data to make new data, to perform some tasks, is where the wonder of Python and Excel lies, at least for me so far on my Python and Excel journey. And all this functionality is easily built in with Pandas, as we saw, which is already loaded into Python and Excel. So I've got this example for you, but I'm just going to say this is a small example because it fits better on the slides. Where the magic really is going to happen is when you have a giant example. And I'm about to give an example of like some school students, and my school only has 20 students, which is not that fun because a kid could be like, I could just do this by hand. So I would recommend that your school has 800 students or something like that, which would be much more fun and much more annoying for them to try and just figure it out with a pencil and paper. Okay, so we're going to solve this mystery. Welcome to the case of the missing snake. It happened at 12 o'clock. The location, the science lab. The victim, banana, the banana python. The notes. After leaving her classroom at 12 p.m., Ms. Monty returned 5 minutes later to feed banana, only to discover that she was missing. So, we have the crime, we have the time, but who could have done this crime? We have some information on hand. The information is, we've got the student attendance for the day, we have the timetables of each student, we have the time it takes to get between different classes, we have canteen purchases from the day, and we also have this side fact that all of year 11 and 12 are off campus today for an excursion. So different pieces of information for this crime that's occurred after period 3 at 12 o'clock on this day. So here's our attendance records, we've got our room walking times in this symmetrical data set here. We've got our student timetables, we've got canteen purchases, and then also we have this handy-dandy detective data toolkit sheet that you can give your kids to hopefully help them with some of the ideas that they can use to put this together. So let's hopefully be able to find out who has released banana, and hopefully we will be able to retrieve banana. Okay. So to give this to students, I would be providing something along the lines of this. I've got all of these different pieces of data already loaded up in here in the different sheets of the table. And then I've given a data analysis template, but you could just go be like, no, figure it out yourself, children. Or you can give more details. You could just give these big headings. Whatever you like, that's up to you. But here are the steps that I'm going to take to solve this mystery here with you today. Firstly, I want to find all the locations in the school that are within a 5-minute walk of the science lab. So we know that's happened in the first 5 minutes of lunch after period 3. So let's find out where you could have come from. Then we're going to find out which students are timetabled to be in that location on this, for this period. Then which students are actually at school today? Some might be sick, some are on that school excursion. We can join those together to work out who was here and was supposed to be nearby. And finally, we can work out if anybody has another alibi. So here we go. We've got our school walk time table here. And what we really want to do is just grab this science row here because it's got all the distances, or all the walking time distances to the science room. So to be able to work with this data, we need to be able to load that walk time data. We're going to set, so because we are working with something, like we could have worked with either column here, but for this example, I'm going to work with the row instead of the column, even though they are symmetrical. But it's just a way you can teach both columns and rows because we'll be working with rows later. Then we can work out which of these ones in this row are within a 5-minute walking distance. Okay, so firstly, we saw how to load data earlier. Super easy. Now we are going to set the index to that location column. So that's saying, hey, this is the label of the column that I want you to use. So when I want to look something up, it's going to be mapped from this key to the data associated with the rest of that row. Then we are able to search for the science row because we've got that science label that we can look up. We can see all of the different places, but we don't want all of those. Some of these are too far away to make it to the science room in time. So here we go. We can now search for, I guess I've said actually we're going for 3 minutes or less here. I guess you need to get in and get out with your snake, actually, to load, get that places that are close to science in this time. So we've now got this list here, which I've gone index set to list. And we're going to keep this in our pocket for later, because we'll be needing to check some students out to rule them out as suspicious or not suspicious. Okay, so we know where the people could have come from. Wow, who was in those potential locations? So we've got our list of English, science, history, and geography over here. Let's apply it to everyone in period 3 here. So, because that's the period that happens before lunch in my fictional school where you have lunch at 12 o'clock. It's all fine. So we need to load that data again. Then we're going to be checking which classes were had in period 3 and only keeping the ones that are in the list of useful data. So here we are working with columns now instead of rows. And we could print out all of the period 3 classes just to be like, oh yeah, that's good. Or we could print out all the kids who had period 3 and who had a student ID. You'll also note they're not student names, so we need to do some data matching up later. Oh no. So here we go. We've got our close to science children who are here. We've got the index, as we said, we had that list already, sorry. And then we want to create, I'm going to call it a filter almost, where we are creating a series of Booleans, which is saying, hey, it's the period 3 class in the list of those ones we mentioned before. And it's just going to go, okay, science, yep, true, false, false, true, true, false. And we're just going to have all of the classes, we're going to have that true, false, true, 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 false, whatever, series list. And we can apply that to the data to filter out everything that is false, which we can do here. So I've done it this way just to make it read a little bit simpler. So you can have your timetables, and we can have that close to science check or bool or whatever you want to call that series you've got there. And it's just going to get rid of everything that was false, which is handy because now they're out because they are cleared of this snake-related crime. And we have just the student IDs of the students who could have done it. Okay, so those are the places people could have come from, but you have to be at school today to actually come from that spot. So let's check the attendance roll to see who was here. We're going to be looking at the status if it was set to present, and as we saw just a second ago, we could easily search through a column. This time we're going to set up a conditional rather than doing the is in. We can just use, much like your if statements, you can say attendance status is equal to present. And then we're just going to get one of those lists again of all the Booleans that we can use to filter out all the kids that were not present today. So we're going to get rid of all those kids who are absent, and we've now limited it down to, I guess we've got all of the kids here now, and they've got the is present. So most of the kids are present today, but we also need to know something. No one in year 11 and 12 is on campus today. They're off-site. So we can also add this secondary filter here, which is called only juniors, because we want to get everyone who is in year 11 or 12, they're out of here. So we're going to filter once again, creating this on-campus Boolean checklist and filter out to get only the junior students who have checked in today, got that tick as attending. Great, okay. So now we know who was on campus today, who's been marked as present and is in year 11 and 12, and we also have that list of the classrooms and the students that were in them that could have made it to the science lab in time to commit this crime. So it's time to join that data, because as you can see, we've got names over here in our attendance roll, but we don't have any names here. It's just going to be hard to start making accusations if I'm like, you S0108, I think you did it. So we can use something that is called pandas merge here. It's super easy to merge two pieces of data if they have a matching field, like the student ID. So super easily, we just map those together, and now we can see we've got our joint data, which is this yellow one here, that was in both. We've got the blue data that came from the on-campus, from the role, and then we've got the green one that is coming from the timetables for the kids. So that's all there together, and we do only have 6 remaining suspects, which is very convenient. Okay, so we are nearly at the end of our journey, but we do have a little more data we can use to work out. We have who was buying lunch at the canteen at the time of the crime. So we can see that we have this time data here for the time the purchases were made. So maybe we can investigate that to sort out this a little bit more. We are working with times though, but I don't know about you, I've never tried to teach date-time objects to a child, and I want to keep it that way. I wanted to keep it that way for you as well, and give them an opportunity to create their own small functions that enable them to interact with the strings. So that's what we're going to be doing. So I created two functions, one that is get hour and one that is get minute. Much easier than dealing with a date-time object that we really don't need. So I've created these two functions, and this is actually a really great place for you to introduce other concepts from your curriculum that you want to be including. I'll talk about that a little bit more later. So I've run my two functions here, applying it to that time field. And I've actually been able to create two new columns of data by setting, just like you could set something in a dictionary essentially, but I can set it to a whole new row of data. So these ones all happen at 12, and here we have the minute column. So that's how you can extend on the data and get students to build out the information that they have. Cool. Now, once we have that, we are able to then also want to see what names these are of the students, because we're once again back to student IDs. We've tapped in, we're buying things at the canteen with our student ID cards, which I think is a thing that actually happens in some places in this day and age. But we're back to not having names, and also some of these kids might have not ever come from a place that was, potentially suspicious. So let's have a look. We've got our alibi list, and we want to say, if you're not, that's what this little tilde here is for, if you're not in the alibi list, we're going to keep you as a suspect. So we can run that and see if we have maybe solved this crime. We have. There is one suspect remaining. It's Mia Kim, and I'm going to leave it as an exercise to the reader as why the delightful Mia Kim has stolen this snake today. But hopefully you've been able to spot all the snakes throughout here, and I think we'll be able to recover Banana, because I think she's around. So, I hope that's been an interesting set of concepts you're able to use in your classroom, but I think there's like a couple of exercises I want to just go through to be like, how can I extend this to what I need to do for my curriculum? So firstly, let's talk about extending this basic example with more data, because there's just infinite amounts of data that you too can make up. For instance, you might want to add more data files. There might be other ways to have an alibi, something like a lunchtime chess club or competition that people have to check in for. Adding more fields to the data, such as for the attendance list, you might have people who have come in late to school or people who have gone home early, so those are more opportunities to introduce more conditions on like whether someone was at the school at the time of the crime specifically. You could also introduce adding or calculating like fuzzy data. For instance, we had walking times, and it kind of assumes that every student walks at the same time. You might have information from their PE subjects to be like, well, Charlie's a really fast walker. He could have got to the science lab and back in that time. Or maybe year 7s always walk slower than year 12s. You could do all of that. Or you could have a crime note and the average number of misspellings of words per different grade levels. You could obviously also include decoy data, just throw the kids right off the center of the trail. There's, of course, the curriculums that we all have that we might need to introduce specific topics like if statements, loops, lists, dictionaries, and more, which, when working with Python and Excel, because it is kind of that more mapping-based filtering data sets functionality, it's just a little bit not the kind of same that you might have for projects that you're already used to using. But with a little creativity, we can introduce them with functions. For instance, maybe every student has a biography that's part of their student profile, and it says things in like open form text that things like that Zoe, she loves being in the string ensemble and the chess club. We know chess club is on Tuesdays when this crime occurred, so let us write a function to see if freeform text includes chess club in it, to see if we can create a new set of data called is in chess club, and can check someone off the list and give them a new alibi potentially with that. Or we could have something more complicated. We want to use a loop. Maybe there's a note left at the scene of the crime. It seems to have a whole lot of long words for a high school age kid. Let's maybe look through each student's bio to see if the proportion of words that are over a certain length matches the proportion of words in this letter that are just exceptionally long for a child. So we could really come up with anything that we wanted there. Finally, maybe Python in Excel isn't for you. You might not be in M365 school, and that's okay. I accept you anyway, because you too can do this in Jupyter Notebooks using VS Code, which is free. And yeah, VS Code is also great because you do have, much like the Python interpreter in Excel, you have these cells where you can just write your code, you can print stuff out after them, as well as the ability to write markdown and instructions. So it might actually be a great way for you or your kids to write down the process of doing this. The only thing you'll need to do with that is a little bit more data crunching to actually put the data into a form to get data out of CSVs rather than it just being in Excel and highlighting that table. So yeah, that is all of my talk today. I hope you have had fun looking for banana with me. And maybe this will be something that you can use in your classroom. Feel free to check out the link. The Jupyter Notebook's not up there yet, but the Excel file with the data examples are in there, and the slides are also in there as well.